How are you? Let us look at triple integrals, but specifically on spherical coordinates. First thing that we need to discuss it is that our x, y, and z will change. Now, how will they change first? Since you are integrating, if you are given a problem in spherical coordinate, in rectangular coordinate, we can rewrite this integral to f of rho, phi, and theta rho square sine phi d rho d phi d theta. Now just understand that this one here, it is rho, this one here, it is phi, this one here, it is theta. Right, it is theta. Now, because we are talking about spherical coordinate, our region that we are going to talk about is actually bounded by a sphere somewhere. Do you understand that? Our region, it's actually bounded by a sphere somewhere. Now, let us look at an equation of a sphere first. Now, the equation of a sphere, is, it is x squared plus y squared plus z squared is equals to a squared, like that. Now, this is an equation of what? Of a full sphere. That is an equation of a full sphere. Now, you know that if a cycle has a semi-cycle, so here we need to have something called a positive hemisphere, which will be given as z is equals to the square root of a square minus y square minus x squared. So that is a positive hemisphere. And we also have a negative hemisphere, right, which is given by z is equals to minus the square root of a square minus x square minus y squared. Right, we know about the hemisphere. Now, what you need to understand by this thing is that whenever we are talking about bounds here, we are only going to talk about a sphere, but we can also include one more function or one more plane, which is going to be a cone. Right. So the equation of a cone is z is equals to the square root of a in bracket x squared plus y squared. This one is positive cone. And then if you have z is equals to minus the square root of a in bracket x squared plus y squared, this one is actually going to be negative. Right. Now, I know that you like to see the pictures of this thing, right? Now, if we draw a cycle in bound and then that is a full sphere. And then if you have something like this, and then that is a positive hemisphere. And if we have something like this, I didn't draw it very well. Right? Right? That, no, it's not drawn like that, guys. Sorry. It's actually going to be something like this. Yes, it's something like this. So here we have a full sphere. This is a positive part, and this one is the negative part. So we shall look at different orientations of a sphere. Another one will be the cone. And in a cone, we actually have two cones. Which right? Now this one here, it is the positive cone, and so that one here, it is the negative cone. Just know the difference between them. So now you know the pictures, right? You know the pictures. Now we are now going to talk about the rho, theta, and phi. But before we do that, let us look at what will be your value of r. Now, do you still remember that polar coordinate we had x is equals to r cos theta, y is equals to r sine theta. Now, in spherical coordinate, and then 0, and z was actually going to be 0. So in spherical coordinate, what we do have, we know that r, it's actually going to be rho sine phi. So when you have an x there, your x will change to be rho sine phi cos theta. Your y will change to be rho sine phi sine theta, and then your z will also change to be rho sine phi. Now these formulas are actually being derived from this equation here, because we understand the distance is x, this one is y, and then this one is r, and that one is rho. So we can actually deduce some of these equations from this diagram here. So Now you know this. Now let us convert a sphere to its spherical coordinate. Now the first thing that you need to know, we need to note that whenever we say x squared plus y squared plus z squared, this actually becomes rho squared. So whenever you see this, just assume it is that. Whenever you see x, just assume it's this. Whenever you see y, just assume it's that. Whenever you see z, just assume it's that. Now, I gave you another equation here. Would say whenever we change from cylindrical coordinate, we also need to include the rho square sine phi, which is the Jacobian of this. So the Jacobian dv in spherical coordinate, it is rho square sine phi d rho d phi d theta. Right. So just know the difference. Now we are actually now going to talk about the properties of the rho, the phi, and the theta. Now let us start with the easiest one. Which is theta. Now what you need to know about theta, it is measured from the xy plane. Right. Now if you have a three-dimensional space like x, y, z, to get the xy plane, we actually remove the z-axis and you'll be left with something like this, if I'm not mistaken. You'll be left with something like that. Which one? This one, it's y, and this one, it is x. Now from this, we know that it is 0 pi over 2 pi 3 pi over 2 or negative pi over 2, does not matter. So, and 2 pi. So whenever you want theta, this theta here, just remove the z-axis and look how is that region bounded if you look at the z-axis. Now you can take a ball, any ball, and look at the top of that ball. What do you see? You will see a circle, right? Which means the region of theta is bounded from 0 to 2 pi. Right. So that is the value of theta. And the value of theta, again, will be described if given a problem in integral form. If given a problem in integral form, then the last two integrals describe theta in polar coordinate. So the last two integral, if you are given a problem in an integral form, I'm just going to show you what is an integral form. The last two integral will give you is going to describe your theta in polar coordinate. We actually done polar coordinate in the above video, if I'm not mistaken. Right, this is theta. This is theta. Let us move on. The next one, it is going to be rho. Now, what is rho? Rho is the distance from the origin to the most outer function you have. Since our most outer function we have is actually going to be a sphere. It's always going to be a sphere. Our outer functions, guys, for spherical coordinate, it's always going to be a sphere. Your value of phi will be measured from 0 rho square root of a. Now, what is that square root of a? Do you still remember the equation of a sphere that I wrote here? This equation of a sphere, which is what? Which is a square. You need to remember that this is actually going to be what? Rho square is equals to a square. Now, to find the value of rho, we just simply take out the square root. So I need to have an a square there. So your rho will always be the constant, is your outermost bound for rho. It is always be the square root of a constant in the equation of a sphere. It's always going to be that. And then your minimum bound for rho is always going to be what? It's always going to be 0. Nothing will change. Nothing will ever change. Right. And if they are if there is a cone or cones, your rho will be different. Your rho will be different. The upper bound of a cone will be different, but sometimes it's not going to be different. If there is only one cone and the upper bound is a sphere, your upper bound is going to be the number, the square root of the number in the equation of a sphere. But if you have two cones, and the upper bound is actually the not two cones, sorry guys, it's not two cones. If you have two spheres, actually, if you have two spheres, your lower and the upper bound of rho will change. Right. So, but just keep in mind that your rho, it is always like that. Nothing will change. And then the last one, but not least, it is the one that confuses many students. Your phi. What you need to understand about phi, guys, let me draw the right. 3 dimensions, it's not for children sometimes. This thing is hard. But I'm just going to remove this one. But just take note that this one, it is X, Y, and Z. Now, your phi, it's measured from Z-axis to Z-axis, which means your Z-axis is your reference, which is going to be 0. Your Y-axis, it's your second reference, which is going to be pi over 2. And your lower or the negative Z-axis is actually going to be pi. Your Z-axis measure the phi value, which means your phi value, it's always going to be 0 phi to pi. This one, the pi, it's the maximum bound of phi. In phi, we cannot have 2 pi. In phi, we cannot have 2 pi. So, what do we mean by that? So, whenever we measure phi will be measured from Z-axis to Z-axis, from the positive Z-axis to the negative Z-axis. Right? So, you need to understand that concept first. You need to understand that concept that phi is measured from the Z-axis to the Z-axis, from the positive Z-axis to the negative Z-axis. And your Z-axis, the positive Z-axis, it is your true reference having an angle of 0 radian. Your Y-axis or the X-axis, doesn't matter anyway. Your Y-axis or the X-axis will always have the second reference of pi over 2 radian, and your negative Z-axis will always have our maximum bound for phi, which is going to be pi. Right? So, your value of phi is very important there. You always going to measure the phi value from the Z-axis to Z-axis. And your phi, your upper bound for phi, it's always going to be pi. I think that is it's clear, right? Now, we have 3 cases of phi. Now, the first one that I wrote here, this one, whenever you have a full sphere, whenever you have a full sphere, you always going to need that bound. These are the bounds that you're going to substitute your integrals whenever you are going to have what? A full sphere, right? And if you have 0, if you have pi over 2, not pi over 2, if you have 0 less than phi less than pi over 2, here we have a positive hemisphere, which means your hemisphere is only bounding the top of the xy plane, which means you're only bounding this part, right? So that is the bound that you're going to substitute. Now, when you have pi over 2 phi to pi, we are actually you are actually looking for the negative hemisphere, which means when your hemisphere lies down there, your bounds for phi, it is pi over 2 to pi, right? And then when there is a cone. Now, this one, it is quite challenging. It is quite challenging, but I'm going to walk you through the process. Now, when there is a cone present, let me just draw the when there is a cone that is perfect 90 degrees. Now, a cone will bound this thing in this form. That will be a cone. Now, that is the cone. And we know that the equation of a cone is given by z is equal to the square root of a in bracket x squared plus y squared. Now, that is an equation of a cone, a positive cone. A positive cone will be looking like that. Right? Keep that in mind. A positive cone will look something like that. Now, we are going to have something like this. That is a positive cone. Now, if you are looking for the value of phi, because your cone is bounding your phi from the z-axis to that cone, which means your phi is bounded in that form. Now, your phi is bounded like that. Now, how can you actually get your value of phi? You can actually derive this formula. You can actually derive this formula from here. But we know that z is actually going to be, let us derive it together. We know that z from here, it is that, z is from here, it's this, x is that, and y is that. So we are going to have rho cos phi is equals to the square root of a. Your x is going to be rho squared sine squared phi cos squared phi, plus your y, it's going to be rho squared sine squared phi sine phi and sine squared theta. Now, if you take out the highest common factor of rho squared sine squared phi, I'm going to be left with something like this. Cos phi is equals to the square root of a rho squared sine squared phi is equals to cos squared theta plus sine squared theta, which is actually 1. You know that this one is actually going to be 1. And then, if you take the square root of this thing here, I'm going to have rho cos phi is equals to rho sine phi times the square root of a. Now, if you can actually, so the rho will actually divide, and then if you divide both sides by and formulate a tan, you have something like this. You'll have the tangent of phi is equals to 1 over the square root of a. All right? And then if you calculate phi from here, you can see that phi, it is actually the arctangent of 1 over the square root of a. So what does this equation mean? It means that whenever you have a positive cone like this, your equation or your value of theta or your maximum bound of phi, it is determined by that equation. Right? So whenever you have a positive cone, your maximum value of phi, your phi value that is going to be here, it is determined by that equation. There is no need of you doing this in an exam. I see a lot of books doing this thing here, which is nonsense. Just know that whenever there is a cone, use this equation to find your value of phi. Now, there are other equations that are being used, right? There are other equations that are being used. You can use them. I don't have any problem, because now if you try to find the other equations from this, you can actually see that if you draw a triangle from that, and then you have a phi here, you have a 1, you have a square root of a, and then this is going to be a minus 1. A minus 1. And then if you say cos phi, your cos phi will be the square root of a over a minus 1. Right. So you can use this equation if you want. If you want to use the sign of phi, it is going to be 1 over a minus 1. There is a problem with this, though. Your a must not equals to what? To 1 to use these two equations. Your a must not, it's actually plus, sorry guys, it's actually plus. It's actually plus. So you can use the equations. It was me that had the problem. It's actually plus. So you can use the equations the way you like. So a may be 0, a may be something. A can be anything that you want. Now, when a is actually going to be equals to 0, it means that no cone is present. When a is equals to 0, we mean there is no cone present. Right. So I think that is a good practice or intuition looking at the thing. Now, what if, because we are working with cone which is upright, what if your cone it is upside down? How can you measure your value of phi? What if your cone is upside down? How can you measure your value of phi? Now, your phi value again, your maximum value of phi, it's going to be pi. But the only thing that is going to change now, it's going to be this minimum value here, which means what will be that phi? You know that this one is pi over 2, yes? You know that is pi over 2. You actually going to take the same, you're going to take this angle that you got from this equation, even though the equation is negative, and add it to pi over 2, or subtract it from pi. You're actually going to get that value. It does not matter. Does not matter. But I highly advise you subtract from 180. I highly advise that you subtract from 180. So that is the brief introduction on spherical coordinate with its nodes, with some equations that we are going to look at when we solve. But in the next video, we are going to look at problem solving. Sharp.